All right, guys. Today we're going to work on section 2.5, which is linear models, and something I should have included here, but I forgot. So if you could add these up here, we have our two forms of linear equations that you need to be using on this section of notes. So the slope-intercept form, I'm sure you guys are very aware of, the y equals mx plus b. But then the other one, which you've probably seen before, and I really like, is the point-slope form, which is y minus y1 equals m times x minus x1, okay? We're going to kind of be using these, both of these. How do you know when to use one? The name actually really helps here. So when you are given or you found the slope and the y-intercept, you're going to go ahead and use the slope-intercept form. So that really makes sense here, given the name, is that if you're given the slope and the y-intercept, you use the slope-intercept form. That is literally why it's called that. So on the other one, if you are given the slope and another point, you would use the point-slope form. So once again, very logical here. If you're given a slope and a point, you're going to use the point-slope form. Okay? All right. So whenever we're doing, and this is kind of going to mainly focus on word problems, because that's what the models are. So whenever you're given linear models, you need to look for 2 out of these 4 clues. And so there's 4 clues possible. You will never be given all 4. You'll never actually, I think, be given 3. You'll always be given 2 out of the 4. So the first clue you could be given is slope. And so the slope is the rate of change. We talked about that last section. So it's a constant change over time. The keyword per is often used there. So they're not going to say the word slope. It's kind of like you have to interpret it as how the situation is changing. So that's kind of the key idea there for slope, is it's the idea of change, okay? All right, the other thing is if you're given the slope, you have to consider it might be negative. They're not going to tell you it's negative. It'll be kind of, you have to do a little detective work there to figure out whether or not it's negative, okay? All right, the next one they might give you is the y-intercept. So the y-intercept, and actually we know that this one is b, and so I always call that the beginning. It's not actually what b stands for in our y equals mx plus b, but it's a good thing to consider, because as you can see here, the y-intercept is the initial condition. So that's like the start of the problem. Where are we at? The y value when the problem starts or time is 0. So that's why I interpret this as the beginning. The slope we know is m, and for that one I might think of it as, I always think of it as the movement, because that's kind of how the situation, like I said, how the situation is changing over time. All right, the next 2 are going to be points. So you might be given 1 point at x comma y, and then you might be given another point, x comma y, okay? And so those are just different conditions, so some connection between x and y values, okay? So yeah, like I said, you're only going to get 2 of these, so you might get the slope and a point, you might get a slope and a y-intercept, you might get a y-intercept and a point, some combination of those, okay? All right, so let's do some practice problems then. All right, so the first one here says that a reservoir has a volume of 500 cubic inches, but is being evaporated at a rate of 18 cubic inches per day. Write a function that describes this relationship. So we have our 2 key numbers there, and so to me, it's kind of clear here that the starting amount here, the beginning, is 500, and so that's going to be my y-intercept. And then the rate would be the slope here. That's how the problem is changing. So every day, it evaporates at a rate of 18 cubic inches. So what I'm thinking there then is that like we said here, the slope might be negative. And in this case, I would say it is. because we are losing water along the way. Okay, so we are losing 18 inches of water, so that to me means a negative slope. I have the slope and the y-intercept, so I'm going to use the slope-intercept form, nice and easy here. So y equals negative 18x plus 500. All right, next up here, how much water will the reservoir have in it after 9 days? And so I kind of need to label my variables here. So the y-intercept was the 500 was the volume. So I'm going to say the y is the volume of the reservoir. And so the x means time. And in this case, it is in days because we were losing it at 18 inches per day. So after 9 days then, that would mean I would plug in a 9 for x there. I definitely think it's fine to use a calculator on this particular problem. All right, and so I get that will be 338, and the units here would be cubic inches. All right, so then how long will it take until the reservoir is empty? Okay, so then that's kind of referring to our y value here. So the y is the volume, so an empty reservoir would be a volume of 0. So I'm going to keep my x there. I'm just going to subtract the 500 over, so negative 500 equals negative 18x, and then we'll divide by negative 18. And that is, x is 27 let's call it 0.8 days. I think it is okay to have 0.8 of a day because that would just mean it's kind of in the evening. All right, next up here, let's see. It says it costs $4.30 to make a 5-minute phone call to Sweden. A 10-minute call costs $5.80. Write a function for the linear relationship. So in this case, what are my clues here? Well, this looks like some connection, right? A connection between an x and a y value. So I'm going to say that that's a point. So I'm going to say it's 5, 4.3. I do think that the x is going to be the time, and then y is going to be the cost. For that, you got to really think about the independent and dependent variable. So does how much it costs depend on how much time you spend on the phone? The answer is yes. It doesn't make sense the other way around, that the time depends on how much the cost is. So then, so that's that. And then I have another point here. So it says if it's 10 minutes, then it's 5.8. So we have 2 points in this case. So whenever we have 2 points, the first thing I would want to do is I want to find the slope. And so I'm going to say m equals, and just like we did last section, we got y2 minus y1 over x2 minus x1. So that's going to be 1.5 divided by 5. I'm going to go ahead and get a decimal for that. And that is 0.3. All right, so I have my slope here. I have 2 points, and so in this case, I'm going to go ahead and use my point-slope form because I have that, okay? So I can use whichever point I want, and so I am just going to use the first point. So we're going to say y minus the y value of the first point equals m parentheses x minus the x value of that same first point. It said write a function. It didn't say write it in y equals mx plus b, so I'm actually allowed to leave it like that. If you wanted to distribute that 0.3 and then isolate y, you certainly could, but it doesn't say to do that, so I'm actually going to leave my answer like that. All right, next up it says how much would it cost to do a 22-minute phone call. So I'll go ahead, since we got some space, we'll do it over here. So let's see. So x is time, so I'm going to say y minus 4.3 equals 0.3 times 22 minus 5. So I'm just going to plug that in there. I can actually go ahead and just add the 4.3 over, so I can just do this all in one calculation. So 22 minus 5 in the parentheses plus 4.3. And if I just type all that in the calculator, I'll get my answer. 0.3 parentheses 22 minus 5, close the parentheses, plus 4.3. All right, so that gives me 9.4. This is money, it's the cost, so I'm gonna go ahead and put a dollar sign in front. I'm gonna say 9.40 since that's how we usually kind of look at money. All right, next up, how much does it cost just to connect to the phone call? So this would be a 0-minute phone call. So just as soon as I kind of dial, I already owe money. And so to figure that out, I'm just gonna plug in 0 for X. If you found the y-intercept, if you put this in y equals mx plus b form, that's actually also this answer. So you actually don't need to do this. You can just look at your y-intercept here. But I left it in the point slope form, which is fine as well. It's going to give me the same answer. And so I'm just going to type it in just like this, add that 4.3 over again. All right, so then y would be $2.80. All right, so let's continue on with this next page. And so I just did a little quick reminder of our two forms of the equation there. So we'll start off here with number 3. So it says a small company buys a copy machine that costs $6,000. After 5 years, it's worth $4,400. So I think actually this piece of information is more clear that that's a point. And so remember, that's one of our clues here that we're looking for. So I'd say that point is 5, 4,400. And it doesn't say how much it's decreasing by every year. It just says that we started off at $6,000. So this to me would be my beginning. So when we first get the copy machine, it is worth $6,000. So that is going to be our B value. But an important thing here is that the y-intercept is also a point. Okay, so whenever you have the y-intercept, it's always 0, comma, whatever the b value is. If you kind of think about where it hits the y-axis, it would always be that 0, comma, whatever. And so that kind of the beginning, the y-intercept works doubly. Okay, so with 2 points then, we're going to go ahead and find our slope. So we're going to say m equals, let's see, 4,400 minus 6,000 over 5 minus 0. So it's going to be negative 1,600 over 5. I'll use a calculator for that. So that comes out to negative 320 for our slope. It does make sense that that's negative because it's decreasing in value, like most things do as you use them. And so I'm going to say here that y equals negative 320x plus 6,000. I'll go ahead and use the slope-intercept form since I do have that y-intercept there. In this equation then, x is the time in years, and then y is the value of the copy machine. All right, so then it says, how long does it take for the copy machine to be obsolete? So obsolete kind of means worthless. And so for worthless, I'm going to say that the value is 0. So 0 equals negative 320x plus 6,000. So then I'll subtract the 6,000 over. I'm trying to write that plus sign there. I'll try it again. There we go, that's better. All right, so we'll subtract 6,000 over, so negative 6,000 equals negative 320x. So then we'll divide by a negative 320. That gives us 18.75 years. Now, I actually don't really think that this is true because it'll never be worth 0 in my mind. It'll always, you can always sell it for the scrap metal. But for the purposes of this problem, we'll say that, okay? All right, what does the slope represent? And so remember, slope kind of represents the movement we have here is 320. So I would say for this, a quick sentence, each year, the value of the copy machine, which I'm not going to write, decreases by $320. All right, next up here, number 16, we have Maria's hired by an accounting firm at a starting salary. It doesn't say starting, but it's a salary of $60,000 per year. So I think that in this case is the beginning. I know it says per year, so usually that's slope, but that's not kind of showing how it's increasing from year to year. That's just that 1 year she gets $60,000. So then it says 3 years later, her salary increases to $70,500. So that to me looks like a point as 3, 7,500. So then we need to remember that the B is also a point, so it's going to be 0, 60,000. So we're going to use those to find the slope here. So we get m equals, let's see, what is this? 70,500 minus 60,000 over 3 minus 0. So that would be 10,500 divided by 3. So that comes out to 3,500. So that's our slope. So that means she's getting a raise of $3,500 every year. And then we can write our equation here. I would use y equals mx plus b since we have that b. 3,500x plus 60,000. All right, so then in this case, oops. I didn't do enough space here. There we go. All right, so in this case, x is the number of years, and then y is her salary for that year. All right, so when will her salary reach $100,000? So we're going to plug that in for y. All right, so I'm going to subtract the 60,000 over, so 40,000 equals 3,500x, and then we'll divide by 3,500. All right, and so that'll be 11.42. So I would say if we need to be over $100,000 per year, I would actually say it'll be her 12th year. So her 11th, because you only get raises once a year usually. So in her 11th year, it will be under 100,000, and then her 12th year will be over. All right, so then last up here, we have a car costs $300 to rent and another 20 cents per mile driven. So I think that the B would be 300 because you have to pay 300 right off the bat. And then the M would actually be a positive 0.2 because I'm going to convert that to dollars there. And so it's $0.2, and so that's the change. So it's going to increase by 0.2 for every mile that we drive. So I'm going to say y equals 0.2x plus 300, and with x being the miles driven, and then y being the cost. Okay, so how much would you have to pay if you drove 1,000 miles? So that would be, let's see, $500 if you type that in the calculator. All right, and then if your bill came out to $400, that's the y value. What would the x be? How many miles did you drive? So we'll subtract that over. 100 equals 0.2x. Divide that by 0.2. So x equals 500 miles.